All right, here we are in chapter 9. This is going to be section 1 that deals with simplifying square roots. So I'm going to start off by defining what square roots are. I'm going to give you a table. Then what we're going to do is we're going to estimate some square roots. We're going to approximate them using a calculator. And then finally, we're going to just learn how to simplify them real quick. It's actually very easy. I'm going to show you a technique to use that will allow you to simplify them very fast. So the first thing, let's recall. That's a horrible looking R. So we're going to recall that a square of a number, all right, is defined as the following. So if n to the second power equals m, then m is the square of n. In other words, and I think it's always good if we use like real numbers. If 5 to the second power equals 25, then 25 is the square of 5. So hopefully now with the number, it like kind of makes sense of what's happening. Now, if we define what a square root of a number is, watch how this definition just changes just slightly. So if n to the second equals m, so notice it's still starting off the same way, then, and here's the difference, n is a square root of m. Now, we're going to use the same exact numbers that we did in the previous, or above on the top of your screen. If 5 to the second equals 25, then 5 is a square root of 25. Now, we do use notation for this, and the notation is what we call square root notation. So make sure that you're writing this down. Write it nice and neat because there's a lot that's kind of going on here. All right. So here's the notation that we're going to use. All right. This is read the square root of m. Okay. Now, the letter m is called the radicand. So that has a special name. The symbol that we use is called the square root symbol. Another word for it is the radical sign. It depends on who you talk to, okay? And finally, there is one more little piece of information that is not written, and we assume it to always be a 2 if it's not written. It's right here. That is called the index, okay? And if there's nothing written there, then we assume it to be a 2. Otherwise, we will write a number there. So you could have like the third root, the fourth root, the fifth root, and that would be a 3, 4, or 5 respectively. However, if we just write the square root of m, we assume that that little number right there is a number 2, okay? So now I'm going to give us a table because this is going to help us with simplifying square roots. And this table is massive. It's so important. So just give me a second here. I'm going to write it down. I'm going to pause the video and then I'll unpause it. All right, I'm back because here is our table. So if you notice across the top, I have the square root of 1, the square root of 4, the square root of 9, the square root of 16, the square root of 25, and so forth. Okay? In the bottom, we can write out what those reduced are. In other words, what are what we call perfect squares. So the square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 4 is 16. I'm sorry, I said that backwards. Square root of 16 is 4. Square root of 25 is 5. Square root of 36 is 6. And if you just follow the trend, I take this table all the way up to 13, but there's more. So what we're saying is the square root of, let's say, for example, 49 equals 7 because 7 to the second power equals 49. So that 7 is a perfect square. So there is a relationship here between a number squared and then taking the square root. Okay? So what we're going to do here for the next couple examples is, and I'm not gonna like really drag this out because we have our table, and this table, like I said, unbelievably important for us. So let's go ahead and let's just simplify a couple because there are ones that we got to be careful of. Okay, so let's say the square root of 36. Well, the square root of 36 is in our table. It equals 6. All right. Now, the next two examples are the ones we need to be careful of. So here's the first one. All right, notice I'm asking for the negative square root of 25. All right, now think about how I said that here. I said the negative square root of 25. The way that we think about this problem is that negative on the outside is really negative 1 times the square root of 25. So what we have to do here is we have to find the square root of 25 first. According to our chart, it's 5. And then we multiply negative 1 times 5, which equals negative 5, okay? Now, if you're asking yourself, well, why do I have to be careful about this? Because now if I look at this example, and this is the square root of negative 25. Now, before I go any further, I'm going to read the first problem again. So let me highlight it as I read it. Negative square root of 25. The second is the square root of negative 25. So notice the difference in the way I read this. Now, here's the problem. Negative 25 is not on your table above. And that is because the square root of a negative number is not a real number. Okay? Even if you got a calculator, all right? And you tried to do it. Let me see if I can get my calculator here. Where are you? Here you are. So notice when I got my calculator, if I type in the square root of negative 25. So hopefully you can see this on your screen. Is there a way that I can key press history? No, I don't want that. I'm trying to see if I can make the screen bigger. Detached LCD. I make that bigger. Oh, look at that. Isn't that beautiful? So square root of negative 25. If I hit enter, it says error, non-real answer. And that's exactly what it should say because negative numbers are not allowed to be underneath the radical sign. Now, if I type in the previous problem, negative 1, even easier. How about this? How about negative square root of 25? Notice when I hit enter, it says negative 5. And that's because the calculator did the square root of 25 first and then multiplied it by 1 or negative 1. Okay? So with these two problems highlighted in blue, they are vastly different problems. One gives you an answer and the other one is a non-real number. It's not a real number. If you take me for Math 108, you will see why. And you will see what the answer actually is. But for us right now, don't even worry about it. So the next thing we're going to do here is we're just going to go ahead and we're going to look at some easy problems. We're going to simplify a little bit here. They're not too difficult. So for example, let's say I wanted to find the square root of 25 plus 144. Well, the first thing you're going to want to do is add 25 and 144 together, okay? And the reason why is they're both underneath this radical symbol. So 25 plus 144 is 169. And then according to our table, if we scroll up, It's the last row or last column, I'm sorry. The square root of 169 equals 13. So that wasn't all too bad. Okay? The thing to remember here is this. The square root of 25 plus the square root of 144 does not equal at all the square root of 25 plus 144. All right, we know on the right-hand side, we get 13. Look what you get on the left side. 5 plus 12, and 5 plus 12 is 17, which does not equal 13. Okay, so do not think you can just separate them. You got to figure out what it is underneath first, and then you take the square root. When we get into multiplying square roots, that's when things change a little bit. Okay? All right, so now the question becomes this. What's the square root of 20? I want you to think about that. What I'm going to do is I'm going to copy and paste our table because we're going to need that. All right, I'm back. And the answer, or the example is, what is the square root of 20? Now notice, in my table, across the top row, I don't see the square root of 20 anywhere. So what we're going to have to do is we're going to have to approximate it, okay? So the square root of 20, if you think about it, it's going to fall in between the square root of 16 and the square root of 25 because 20 is in between 16 and 25, okay? So the square root of 20 is going to be in between the square root of 25 and the square root of 16, which means if we were to get out a calculator, the square root of 16 we know is 4 according to our table, and the square root of 25 is 5 according to our table. So the square root of 20 has to be somewhere in between 4 and 5. So if you were to take a guess, I would say it's probably something along the lines of like 4.4 or 4.5. And the reason why I'm saying that, 20 is 4 units away from 16, and 20 is 5 units away from 25. So I think it's going to be somewhere right in the middle. I would be leaning really close to 4.4. So now the question becomes, okay, well, how do you use a calculator to do this? Well, it depends on your calculator, to be honest. I'm going to show you 2 ways. First way is if you have this fancy one that I have right here. Okay? Let me there we go. So if you got this fancy one that I have right here, you can literally type it in exactly how it looks. Now, my square root button is all the way on the left-hand side, and if you can't, if you got a different calculator, it's going to be somewhere else. So you got to try to scan and look for it. But notice, and it might be kind of hard to see, but my square root button is right above the x squared button, and it's in blue, which means I have to hit the blue button first. Now I got the square root symbol, and I literally just type in 20. And remember, my guess was like, what, 4.4? So when I hit enter, I get 4.472. So we'll round this to 2 decimal places, so it's 4.47. All right, so let's go ahead and let's just minimize that. So the square root of 20 is approximately 4.47, and that's what this symbol right here means, approximately. Now, if you have like an older style calculator, one that's like not as fancy as mine, and it's the worst calculator ever created, which is like your cell phone calculator, all right, you may get lucky, and there may be a square root button on the calculator. So if I'm using my computer calculator, it's right here. But what you got to do is you got to type in the number first. So you type in 20 first, and then you hit the square root button. And it'll give you the answer, 4.4721, all that stuff. But we rounded to 2 decimal places. Okay? So you got to be careful when you are thinking about your calculator and how to use it. All right? So let's do one more example like this. All right? I'm just going to erase the screen because I want to keep my table up there. So I'm going to erase the screen, and we'll do another example where we're going to approximate and then use our calculator to figure it out. All right, so if you look in the upper left-hand corner of your screen, we got a new example. It's in red. It's the square root of 79. Now, if I look at my table right here, I know 79, or the square root of 79, is going to be in between 8 and 9. So how I write this? Square root of 64 less than square root of 79, which is less than the square root of 81. And I know square root of 64 is 8. Square root of 81 is going to be 9. Now the question becomes, all right, well, if you were to take a guess, what do you think it would be? Well, if I think about this, 79 is only 2 units away from 81. It's only 2 units away. However, 79 and 64 is a difference of 15 units. So 79 is so close to 81, which means my answer is going to be really, really close to 9. So I'm going to guess 8.8 or 8.9. And to be honest with you, I think I'm going to lean towards 8.9. Now, the only way to be sure, and if we round it to 2 decimal places, is to get out our calculator. So I'm going to use the calculator on my computer again. I'm going to type 79 first, hit the square root button. And notice if I round this to 2 decimal places, it's going to be 8.89. 8.89, which if I were to round that to 1 decimal place, I would have rounded to 8.9. So I feel really, really good with my guess. Oh, I used the wrong symbol. We got to use the approximation symbol there because we're estimating what it is. Okay? So now the last thing I want to do is show you how to simplify using square roots when we have variables. And it's very easy. Okay? So we're going to start off with a really simple problem here. We're going to take the square root of x to the second. Now, if I can kind of use some knowledge that I have previously, check this out. We know the square root of 25 equals 5. However, if you didn't think about this, I can actually rewrite that 25 as 5 to the second power. And notice that when I take the square root of 5 to the second power, I'm left over with the base. Now, there's a reason for that. I'm not going to tell you yet. When we get into the true definition of what the exponent is and everything, I will show you. But notice another example. Let's do square root of 9. Well, that's going to equal 3. But if you think about it, I can rewrite that 9 as 3 to the second power. So it's the base. Let's try one more. Square root of 121. Well, 11 to the second power equals 121. So if I just take that 11, I know that's going to be my answer. So if you're following along with the pattern, the square root of x to the second power is just x. That's all it is. Okay? Now, there's a reason for this. And there's a really easy way to think about this. And the way that I like to go ahead and approach these problems, like let's say the square root of x to the 8th, is I'm going to go ahead and kind of group them into things that I know. Like, for example, I know x to the second times x to the second times x to the second. I know is going to equal, oh, I need one more. My bad. So I know when the bases are the same and you're multiplying, all you got to do is add the exponents. So 2 plus 2 plus 2 plus 2 is 8. But more importantly, the way that I think about this is, and we just looked at this example right here, x to the second equaled x. So I know this will simplify down into x. This simplifies down into x. This simplifies down into x. And then that will simplify down into x. And if I multiply all these together, I will get x to the 4th power. So the square root of x to the 8th is x to the 4th. And the reason behind it is x to the second. If you think about it, the square root is just x. And I have 4x to the seconds underneath that radical symbol. So I'm going to have 4x's all multiplied together. Now, this is the long way to do it, but there's an even easier way to do it. Let me show you this way. Same exact problem. Remember back earlier in the video, I said there's a number out here. It's called the index, and it's a number 2. Well, the easiest way to do this, to be honest with you, is if you're asked what's the square root of x to the 8th, all I want you to do is take the index and the power underneath the radical symbol and just divide it. 2 goes into 8 4 times with a remainder of 0. This 4 will always be your exponent in your answer. Now let me prove it to you. We'll do another example. How about x to the second? Well, we know there's a 2 out here. So if I just divide, 2 goes into 2 once with a remainder of 0. And notice that means I'm going to have exactly 1x outside. So I just put x. And it's that easy. Remember, that's going to be the exponent, that little 1. If I kind of expanded this problem about x to the 24th, well, I don't want to sit here and write, all these x squareds. All I'm going to do is understand that my index and my exponent underneath the radical, I'm just going to divide them. 2 goes into 2 once. Drop down to 4. 2 goes into 4 twice. This number right here is going to be the number of x's on the outside. I just write it as the exponent. So the square root of x to the 24th is x to the 12th power. Now, this just doesn't apply to one variable. This will apply to multiple variables underneath the radical. The only thing you got to do is just kind of, if you want to, you can come underneath and say, okay, well, we're going to do the x first. 2 goes into 4 twice. So I have 2 x's. Now we're going to do the y. 2 goes into 2 once. And now I'm going to do the z. 2 goes into 8 4 times. So the square root of x to the 4th, y to the 2nd, z to the 8th is x squared times y times z to the 4th. And that's it. Your book does not go over this technique. I highly suggest that you do your problem this way. This is the only time where you're ever going to hear me say, I kind of want you to do it my way, because my way is so much easier. Now, we can combine everything that we've learned into one problem. Let's say we wanted to find the square root of 64x to the 12th, y to the 16th. Well, the hardest part here is knowing what the square root of 64 is. Square root of 64 is 8. Underneath, we're going to do the x's. X goes into 12 6 times. And then we'll do the y. 2 goes into 16 8 times. So your final answer is 8 times x to the 6th times y to the 8th. And I gotta be honest with you, that is as hard as this gets. If you can just maintain what's going on and understand that what we're looking for are like exponents of 2, this is easy. Let's do one more like this, and we'll wrap it up. What is the square root of 144, p to the 12th, q to the 20th? Well, you got to know what the square root of 144 is. The square root of 144 is 12. Now, let's do the p. 2 goes into 12 6 times. So that means p to the 6th. Let's do the q. 2 goes into 20 10 times. So we got q to the 10th. So the square root of 144, p to the 12th, q to the 20th equals 12 p to the 6th, q to the 10th. And that's it. So in the next video, we're gonna start learning, okay, well, what if you don't have these nice numbers like 144 or 64 or 25 or something like that? So I'll show you how to actually reduce them without using a calculator. So see you in the next video.